Hello and welcome to the Radicals. Today I will be sharing an important lesson with you all. We all will be discussing about how to factorize an algebraic expressions or algebraic quadratic equation. This is the second part of the first series of factorize an algebraic quadratic equation. So let's begin. This is the third video lesson of Algebra Basics where we are going to talk about how to factorize an algebraic expression part 2. So here, whenever we are going to talk about factorization of polynomial, first we have to see that there are basically three methods to factorize. If we have the first method, like when we are going to have any expression, we must go and take common, even if other methods are available. For example, if we have 20x squared plus 5x, we must see what is common and then we have to solve further even if the other methods are applicable. Then we have to check next for squares of numbers in between if there is a negative sign. If we have two numbers are the squares or in between there is a negative sign, we must take the square root and write ones with plus and ones with minus. Which is, for example, if we have 100x squared minus 25, we can see that 10x plus 5, 10x minus 5 is the solution to this particular example. Then if we have an equation ax squared plus bx plus c, this is the quadratic equation of three terms or simply trinomial. So we are going to discuss this type in detail. But before moving on, let's tell you that if you want to go for first two methods in detail, go to description box and get part 1 video tutorial link. Or do not forget to subscribe my channel. You will get notified for all the new videos. Let's go to this particular type of quadratic equation and factorize it in detail. There are certain methods. For example, the first method is to multiply the coefficient of k squared with constant. Write all possible factors of the product answer gotten in step 1. Then replace the middle term with the best suitable pair of factors among all factors and then take common in first two and next two terms. Then take common for one expression from all the terms and write leftover in the next bracket. You can recap this part of the video after taking the first example. So let's move on to the example and then you can come back to this part to recheck all those steps back again. For example, if we have 14k squared plus 49k plus 21, first, as I mentioned, always go and check what is the common factor, as it is the first priority step. Once I've taken 7 as common, now in this way 7 is shifted to the other side and finished by dividing it with 0. So we are left only with this equation 2k squared plus 7k plus 3. Now let's start factorizing it with all the steps of factorization that we have just discussed in the last 2 minutes ago. So first step is to multiply the coefficient of k squared with the constant. In this case, we have the coefficient of k squared as 2 and we have to multiply it with the constant which is 3. So multiply 2 with 3 is 6. Now, we have to see that after taking the factor of 6, we have to see that which is the suitable factor to replace it with the middle term. As we know that our middle term is 7k, so the best pair is 1 into 6. But the next factor 2 into 3 is not a suitable factor because if we add them 3 plus 2 or 3 minus 2 is not equals to our middle term which is 7. So we are going to take 1 multiplied by 6 as the pair of the best suitable factor because 1 plus 6 is 7. Now we know that if we replace the middle term 7 with these factors, we have to write k with both the factors because 7k is written. So 7k can be substituted with 1k plus 6a. But rest of the terms 2k squared plus 3 as it is. Now we have to take common from the first two terms and the next two terms. So the first two terms after taking common we have k into 2k plus 1 then plus 3 k 2k plus 1 is equals to 0. Which means that in the last step, we have to see if 2k plus 1 and 2k plus 1, they both are the same. factors, first again we have to take common 2k plus 1, and what is left before this bracket is k. What is left before this bracket is plus 3. So this are as the roots of our equation. Now let's go to factorization of quadratic equation, next example. Now let's do step-by-step factorization. Is there any common factor in it? No, there is no common factor. So what do we do directly? We will start it from the first step, which is to multiply the coefficient of b square with 56. So take product of the coefficient of b square, that is 1, and 56, which is 1 multiplied by 56 is equal to 56. Now we have to take the pairs of possible factors of 56, which is 1 into 56, 2 into 28, 4 into 14, and 7 into 8. Which should be the possible best factor to replace it for the term 15b? So let's start looking at it. If we add 56 and 1, it is 57. And if we subtract, it is 56 minus 1, which is 55. So it's not to be considered. Then if we take 2 into 28, we have to add them and we get 30. And if we subtract them, we get 26. So this is also not to be taken. Now let's check the other factor, which is 4 into 14. If we add them, 4 plus 14 is 18 and 4 minus 14 is 10. So it means this is also not a suitable pair of factor. Now the last one which is left, which is 7 multiplied by 8. So if we add this, 7 plus 8 is 15. Yes, this is the correct pair of factor which we can take to replace for the middle term. In this case, we have b square minus 7b minus 8b plus 56 because we have replaced this 15b with 7b and 8b. But why we have decided for both of them minus sign? Because we had 15 with minus sign, and we know that if we have to add both negative numbers, then only we are having the possibility of adding them, and the resultant is always negative. The next step is to take the common from first two terms and the next two terms. So if we are going to take common from these two and common from these two, we have to see that b is the common from the first term and 8 is the common from the next term. But what if this minus sign, please make sure just because of this minus sign, you have to replace it. This minus sign would remain as it is, and we have to replace this positive sign just because of this minus sign. So when we take common 8 outside, because of this minus sign, all inner signs are changed. As b was negative in this case, b is positive. As 56 was negative, so 8 sevens are 56, but the sign of 56 or 8 sevens are 56 would become changed, which is minus 7. Again, the next step we have seen that b minus 7 and b minus 7 is same. So we have taken common b minus 7 and we can see b minus 8, which is left before this bracket, is now here. We have b minus 7 into b minus 8. Now, we can say that b is equal to 7 and b is equal to 8 are the roots of this quadratic equation. Let's move on to another example. Can you see anything common here? Yes, 3 is common here. So 3 will be shifted to the other side of equals to, which is equals to 0. Again, we have to go for multiplying the first factor, coefficient of m square, with the last term c, which is 6. 6 6 are 36. So let's go to see what are the possible factors of 36. When we take the first factor 1 into 36, and if we want to replace it for the first term, we see that 36 plus 1 is 37 and 36 minus 1 is 35, which is not the suitable factor. Now let's check the second factor, 2 into 18, which is also not suitable because if we add or subtract them, it's not equals to 13. If we go for the third one, 3 plus 12 or 3 minus 12 is not equals to 13. But if we go to 6 6 are 36, that 6 plus 6 is 12 and 6 minus 6 is 0. It means this is not the suitable one. We have left with only one factor, which should be the best possible factor, but let's check. If we add 4 plus 9, yes, it is equals to 13. So let's replace 13 with 4 and 9. Again, we must be considering that 13 is having m as variable, so we must be replacing 13m with minus 4m and minus 9m. Now, the next step is to take the common, and When we take the common, we see that 3m minus 2, 3m minus 2, again keeping it in mind that this minus sign should be as it is over here, and just because of this minus sign the inner side is changed, and then we have two brackets are same, 3m minus 2, so we have taken again common 3m minus 2. What is left before this bracket is 2m, what is left before this bracket is 3 minus 3. So now we can see that 3m minus 2 is equals to 0 and 2m minus 3 is equals to 0. As we know that we have to take 2 to the other side and 3 to the other side and isolate for m, we get that m is equals to 2 by 3 and m is equals to 3 by 2 are the roots of this equation. I hope you have watched the video carefully. For more details, subscribe to my channel and contact us for extra practice material. You can email us at info.theradicals@gmail.com. You can also go to our Facebook page, The Radicals Tutor Online. Make sure you subscribe my channel so you get notified for all the new videos. Thank you.